let's jump right into today's explainer. We're taking something that honestly can feel like pure magic, a mysterious black box of technology, and we're going to break it down into a perfectly logical system. Today, we're demystifying software, tracking that incredible journey from a simple spurk of an idea all the way down to functional execution. Okay, so let's start with our big hook question. How do complex, kind of messy human business ideas actually tell a machine's physical hardware what to do? I mean, the machine itself only understands binary language, right? Just ones and zeros. And for a human programmer sitting there writing out billions of ones and zeros to direct a computer, well, that would be an impossibly slow and tedious task. There's just no way. So how do we actually bridge that massive gap? Well, here's our roadmap for this explainer. First, we'll look at the language of computers. Second, system software explained. Third, application software explained. And fourth, what exactly is software engineering? All right, let's dive right into section 1, the language of computers. At its absolute core, software is simply a set of programs, a sequence of instructions that allows users to perform a specified task. You can think of it as the ultimate translator. It's responsible for directing all computer-related devices and telling them exactly what to do and how to do it. Because, like we said, writing in raw binary is way too tedious, software programmers write these instructions in human-readable languages, things like Java, Python, or C#. Later on, this human-written source code gets converted so the physical machine can actually execute it. Pretty cool, right? Moving right along to section 2, system software explained. Now, what's really interesting here is this big split. Software is broadly classified into two massive buckets. On one side, we have system software, which is basically the low-level background worker managing the hardware. And on the other side, we have application software, which represents the daily tools you and I actually click on for end-user functionality. Let's tackle that background worker first. System software is this low-level software that is constantly running in your computer's background. It maintains the hardware and basic functionalities. In fact, it is literally the very first thing that gets loaded into the system's memory the exact second you turn your computer on. Without it, you wouldn't be able to run anything else, because it fundamentally manages the interaction between the hardware itself and you, the user. And the most famous classification of system software is, of course, the operating system. This handles the execution of programs and offers general services that allow everything else to run over the computer. You rely on these every single day. We're talking consumer staples like Windows, Mac OS, mobile operating systems like Apple's iOS and Android, all the way to powerful open-source systems like CentOS, Linux, Ubuntu, and Unix that run the world's servers. But you might be wondering, how does that operating system actually talk to the specific physical parts attached to your computer? Well, that brings us to device drivers. A device driver is a specific type of software that operates or controls a hardware device linked to your system. They essentially translate the commands, so whether it's your motherboard's BIOS, a USB device, your printer, display, or your sound card, drivers ensure your system can easily talk to that hardware without skipping a beat. Now, firmware is a slightly different beast. It's a unique type of permanent software. It's embedded directly in the system's read-only memory, or ROM, to provide low-level control. Think of it as a set of instructions permanently baked right into the hardware itself. You'll find firmware everywhere, in computer peripherals, everyday consumer appliances, and all sorts of embedded systems. To wrap up our system section, we have utility software. Now, technically, a computer will run even if it doesn't have utility software. But believe me, you absolutely want them to exist. Utilities are developed to provide support in analyzing, optimizing, configuring, and reliably maintaining a computer. Think of tools like WinZip for compressing your files, or Windows File Explorer for navigating your hard drive. They essentially do all the vital housekeeping. Which brings us to Section 3, Application Software Explained. So, shifting gears to end-user programs. These are categorized strictly by their specific functions and use cases. As you can see, we've got word processors for documentation, databases for managing massive amounts of data, multimedia for video and image editing, and web browsers for fetching web data. Let's look a bit closer at each of these 4 types. First up, think of word processors as the modern canvas for human ideas. Rather than just typing data, these applications allow us to securely store, format, and materialize our thoughts so they can be shared globally. Whether you prefer MS Word, Apple's iWork Pages, Corel WordPerfect, or Google Docs, these tools flawlessly translate our human intent into a structured, readable format. Moving deeper,
Database software, also known as a database management system, acts as the structural backbone of modern business logic. Now, this isn't just simple storage. These are massive organizational tools. Platforms like Oracle, MS Access, SQLite, Microsoft SQL Server, FileMaker, DBase, MariaDB, and MySQL allow companies to create, manage, modify, and instantly retrieve huge amounts of data, completely organizing how a business operates on a day-to-day basis.
Then, of course, there's multimedia software. This is where human imagination is translated into pixel-perfect binary execution. These highly demanded tools enable users to play, create, or record images, music, and video files. Graphic design companies rely heavily on powerhouses like Adobe Photoshop and Illustrator, or video editors like Windows Movie Maker, or even Picasa and Windows Media Player to craft everything from simple posts to high-end marketing creatives.
And finally, web browsers. These act as the ultimate applications, connecting your local system software to global servers. They are the primary tools we use to browse the internet, positioning and fetching data from all across the web. Chrome, Mozilla Firefox, Internet Explorer, Opera, Microsoft Edge, UC Browser, and Apple Safari. These basically serve as our daily portals to the massive digital world.
All right, on to our final section, Section 4. What is software engineering? Building software is this massive, collaborative, multi-layered environment. It's a highly coordinated effort where people working on user interfaces, user experiences, and core code are simultaneously crafting complex instructions for execution. This is the true craft of building software. We're moving from a solo programmer writing simple scripts in their bedroom to teams of specialized developers architecting vast digital ecosystems. So, formally, software engineering is defined as the establishment and use of sound engineering principles to obtain software that is economical, reliable, and works efficiently on real machines. I really want you to notice those powerful words there: economical, reliable, and efficiently. This isn't just mindlessly typing code in a dark room. It's a true, rigorous engineering discipline meant to function flawlessly in the real world.
Which brings us to the end of our explainer. We've journeyed all the way from messy human ideas to strict machine languages, through foundational background systems up to complex end-user applications, and finally to the rigors of actual software engineering. So with all these concepts and tools now at your fingertips, I want to leave you with this provocative question. What reliable software will you engineer next? Keep exploring, keep learning, and thanks for joining me today.